Alrighty, in this video, we will be talking about partial fractions, but before we do that, let's go ahead and talk about some AB review. So looking at number one, we could look at this and think about long division or synthetic division for this one right here to rewrite the integral. What I'm going to do, because it's easiest for me, is use synthetic division. Remember, with synthetic division, you're just looking at the coefficients, making sure that they are in descending order. So that's good right here. And then just use synthetic. Oops, that should be a 1. Once you do synthetic, you are going to get a remainder of 2. That's fine. So I could rewrite my integrand to be x minus 4 plus 2 over x minus 1 dx. And then if I were to take the integral of that, that's just going to be 1/2 x squared minus 4x plus 2 ln of x minus 1 plus c, making sure that your x minus 1 is in absolute value bars. Now, the goal of today's lesson is essentially what happens if I flip this integrand right here and it becomes x minus 1 over x squared minus 5x plus 6. So something like this. Well, the thing about this is that I can't really use any techniques that we've learned back in AB, so that's why we have something called partial fraction decomposition, where I'm essentially breaking this apart so that it is essentially a sum or a difference of a rational function that we did back in Math 3. So remember how in Math 3, we probably had something like 1 over x minus 2 plus 1 over x plus 3, and we told you find the sum. Now, if I give you the sum, in this case, x minus 1 over x squared minus 5x plus 6, how can we go back so that this looks something like this right here? Now, partial fraction decomposition only happens whenever the denominator has a higher degree than the numerator for its work. Now, if the denominator has a smaller or the same degree, then we could either use long division or maybe we can divide it out and then see what happens afterwards. And that's going to happen with number 4. But looking at number 3 here, here's our process on partial fraction decomposition. What I'm going to do is go ahead and break up the denominator so that it is x minus 1 and then x minus 3, x plus 2, x minus 2 dx. And then what I'm going to say here is, because I want to break this up into 2 irrational functions, I'm going to have a and then x minus 3 plus b, x minus 2. And a and b are going to represent coefficients, constants that we want to find, so that it gives us x minus 1, essentially. So we have x minus 1 over x minus 3, x minus 2 that we want. Now, looking at the first part right here where I have a over x minus 3, because I want this to be the same thing as this now, I'm going to have to multiply by x minus 2, aka my little LCD here. So I'm going to have a minus 2. And then likewise, for b here, I want an x minus 3 so that I have my LCD. Now, you'll realize immediately that because my denominators are all the same, I could just ignore that, and I could just look at my numerators. So I just have a x minus 2 plus b, x minus 3 is equal to x minus 1. So what we need to do is figure out what my a and b values are. In order to do that, what we're going to do is think about zeros. So here is what I mean by looking at zeros. I'm going to pretend that x is 2. Now, if x is 2, notice how the a's will cancel out because 2 minus 2 is going to be 0. So then I'm just left with b, 2 minus 3 is equal to 2 minus 1, or negative b is equal to 1, which gives me b to be negative 1. Likewise, if I pretend x to be 3, notice how the b's will cancel out, and I'm just left with a, 3 minus 2 is equal to 3 minus 1, or a is equal to 2. Okay, we found our a and b values, and we haven't done any real calculus yet. We just found the partial fraction decomposition so far. So we found out that a is 2 and b is negative 1, so we're just going to plop that in our original. So we have 2 over x minus 3 minus 1 over x minus 2 dx. Once we do that, we could finally take the antiderivative of this. So now we have 2 ln of x minus 3 minus ln of x minus 2. Make sure that they are in absolute value bars and not parentheses, plus c. And this will give us our final answer there. So, as a review, what we're going to do is split this up into 2 fractions, find my a and b values by looking at what my LCD is and thinking / pretending if x is 2 and x is 3, basically whatever cancels out here so that we only have one variable. And then once we get those a and b values, plug it back into my integral and then integrate like normal. Okay, so let's go ahead and look at number 4 here, where we have a 2x squared plus 15x minus 18 over x squared plus 6x minus 7. Now, like I said at the very beginning, in order to use partial fraction decomposition, our denominator has to be bigger at the bottom. In this case, we can't really do partial fraction decomposition just yet, but what we are going to do is use division. Now, there are 2 ways that I like to use, well, there's 2 ways to do it, but there's one way that I like in terms of doing division in this right here. I'm not going to be using long division here. Theoretically, you can, but what I'm going to do is think about how I can make the numerator in terms of my denominator here. So notice how here, if I have x squared plus 6x minus 7, and I have a coefficient of 1, and this is the coefficient of 2, then what I'm going to do is try and make 2 copies of x squared plus 6x minus 7 here, and see what I get. Because what I want, like I said, is 2x squared plus 15x minus 18. That's our end goal. Oops, plus something is equal to 2x squared plus 15x minus 18. Now, if I were to simplify this, I'm going to get 2x squared plus 12x minus 14. That means that my end goal, I need 3x more, 12 to 3 to get 15, and I need negative 4 more to get to negative 14 to negative 18. Now, to rewrite this as my little integrand right here, what I'm going to do is think about, hey, I have the integral from 2, I'm just rewriting the numerator now. Now, if I rewrite the numerator, what you'll notice that if I split this up here, the x squared plus 6x minus 7 on the first terms will cancel out. So I'm just left with a 2 plus 3x minus 4 over x squared plus 6x minus 7 dx. Now, once again, theoretically, if you want to use long division, you will get the same answer. in terms of dividing my integrand. What I'm going to do now is go ahead and split this up. So I have the integral of 2 dx plus the integral of 3x minus 4 over x squared plus 6x minus 7 dx. 2 dx I'm not going to really worry about just because I know that's just going to be 2x. The only thing that I'm going to worry about now is using partial fraction decomposition of 3x minus 4 and x squared plus 6x minus 7. All right, in order to partial fraction decomposition, once again, I'm going to go ahead and factor out my denominator so that it looks like, what is this? X plus 7 and x minus 1. So I'm going to have a x plus 7 plus b x minus 1 is equal to 3x minus 4 over x squared plus 6x minus 7. Now, it doesn't matter if this goes with A or this goes with B, because either way, you're going to get the same answer. But now what we're going to do is think about my LCD here. Here, I need an x minus 1. Here, I need an x plus 7. And then just like how we did in number 3 here, the denominators will cancel out and go away. So I'm just going to shorthand this so that I have a x minus 1 for my LCD plus b x plus 7 from my LCD is equal to 3x minus 4. All right. Once we get to this part, just like number 3 here, I'm going to find x values where I can cancel some things out. So I'm going to pretend that x is equal to 1. That way, the a will cancel out, and I'm left with b, 1 plus 7 is equal to 3 times 1 minus 4, or 8b is equal to negative 1, which gives me b to be negative 1/8. If I pretend that x is negative 7, I'm going to have a negative 7 minus 1 is equal to 3, negative 7 minus 4. So that's going to give me negative 8a is equal to negative 25. Solve for a, I'm going to get 25 over 8. So then that is going to give me the integral of 25 over 8 of x plus 7 minus 1/8 x minus 1 dx. If I integrate this, then that's going to give me 25 over 8 ln of x plus 7 minus 1/8 ln of x minus 1 plus c. Now, that was for my partial fraction decomposition right here. So it was for this integral right here. Don't forget that we still technically have the integral of 2 right here. So we are going to plot that as my final answer. So my final answer here would be 2x plus 25 over 8 ln of x plus 7 minus 1/8 ln of x minus 1 plus c. And that is my final answer. All right. I'm going to go ahead and do number 5, last one. And then you guys can finish up 6 and 7. Number 5, once again, I can't really do partial fraction decomposition right here, and I can't really do u sub here because if I do u being x squared minus 4, then du has to be 2x, but I have an x cubed, so I can't really do that. So before I take on partial fraction decomposition, I'm going to have to use either long division or making copies. Here, I'm going to make copies. Notice how here I want a 2x cubed. That's my end goal in terms of my x squared minus 4. So here, I need an x and I need a 2 right here. So I'm going to make 2x copies. And making 2x copies is going to give me 2x cubed minus 8x, which means that I'm going to have to add 8x for me to cancel out with this negative 8x here. And then if I were to, once again, think about putting this in the integrand, I'm going to have 2x, x squared minus 4, plus 8x. The x squared minus 4 is going to cancel out. So now I'm left with the integral of 2x plus 8x over x squared minus 4 dx. Go ahead and split this up. So we have the integral of 2x dx plus the integral of 8x over x squared minus 4 dx. And then what I want you guys to do is pause the video, try your partial fraction decomposition, and see what you get. If you do that, you're going to get a, x plus 2 plus b, x minus 2 is equal to 8x. I'm going to pretend x is negative 2 to cancel out the a. That's going to give me negative 4b is equal to negative 16. B is going to give me 4. Now, if I pretend x is 2, the b is going to cancel out. So then I'm going to have 4a is equal to 16. A is equal to 4. So notice how here both a and b will be 4. So then I have the integral of 4x minus 2 plus 4x plus 2 dx. And then, of course, I still have this integral technically. So then my final answer is going to be x squared for my blue integral plus 4 ln of x minus 2 plus 4 ln x plus 2 plus c. Now, if this was an FRQ, just leave it like this, call it a day, you'll be fine. If this was an MCQ, they like simplifying, so you will probably not see this, but you'll probably see something like this here, where we multiply the x minus 2 and the x plus 2. And honestly, you can multiply that also. So then you might see something like this. But then you might also see something like this. As your final answer. Notice how I took away the absolute value bars because x squared minus 4 to the 4th will always be positive. But that's just a little practice on simplifying / if you see it on the MCQ. If you leave it like this, I hope you don't. If you leave it like that, you'll be fine. All right, for extra practice, go ahead and do 6. And then doing 7. Notice how for number 7, this is a definite integral. So you're doing the same thing as we done for the other problems, except now you're just evaluating from 0 to 4 in this case. And then it tells you to give an answer as one term. So that's that.